this. Okay, so again, so far we've learned how to solve some quadratic equations, specifically those that can be factored, right? Or those that are in the form x squared equals r, where we just take the square root of both sides. And those are the examples we just did with the warm-up. We're going to look now at some other ones that can be solved by another method, okay, which is going to be called completing the square. So let's take a look at the first example. So look at part A, okay, and think about part A in the same fashion that we just looked at those warm-up examples that we did a minute ago. Johnny, you see there's a square on the left-hand side, so how do we get rid of the square there?
Square root.
Yeah, you square root it, good. So let's go ahead and do that. So part A, when we square root this side and we square root this side, this becomes x minus 2, but we have to remember that this is plus or minus root 3. It's plus or minus because, remember, when we're solving an equation and we take the square root, we have to consider the plus or minus value of this real number here. Okay? Again, if you think about this for a second, it doesn't matter whether this were negative or positive, because either way, when you square it, you're going to get back to what you had. Okay, so for this problem, this is where we're at. How do I get rid of the negative 2? Normal operation?
You add it.
Just add it. And what we're going to do again is we're going to write it like this. 2 plus or minus root 3. Okay? Again, just like we did in the warm-up example a minute ago, we're taking the 2 that we're adding, and instead of putting it on the end over here, we're going to put it in front. Okay? If it were a minus 2, we put a negative 2 in front.
Can I move that so I can see?
Okay? Let's take a look at part B now. Let's take a look at part B. No different whatsoever. Okay? No difference here. Let's get rid of that square. We have 2x minus 5 squared equals 8. So get rid of the square. We have 2x minus 5 equals plus or minus radical 8. Now, at this point in time, you can do two things. You can start moving the 5 over and then divide by the 2. Or you can break up the root 8 first to make it a simpler form. It doesn't really matter as long as the root 8 gets broken up in the end. Okay? But remember that root 8 is really root 4 times root 2. So we can break it into 2 root 2. Alright, so again, think of this as root 4 and root 2. Okay, plus or minus 2 root 2. Now, let's move the 5. How do we get rid of that 5? Add it. Okay, so we put the 5 in front again. We take the 5 and we add it. And when we add it, we want to take it and move it from here right into the front over here. And then get rid of the 2 finally, just divide by 2. Guys, please don't eat all your candy in first period, because I know a lot of you got candy for stuff. Okay, I'm saying that because you're going to be on a little sugar high, and then you're going to be like, by sixth period. Okay? For real. Now, for this kind of a part of the problem here, we want to think about the fact that we have 2 components of the numerator, and we want to break this into fractions. So, take the monomial in the denominator and divide it into both. Okay? And we're going to leave it in fraction form. When I do the 2 over 2 here, what's going to happen to these 2's? They cancel, yeah. So we're just left with the radical 2 there. Again, remember that when we're dividing these 2's, they're going to cancel. But the 2 and the 5 still have to be divided. And that's the 5 halves in the front. Okay, as a solution set, we simply write brace 5 halves plus root 2, 5 halves minus root 2, close brace. Okay? Any questions on this one? It's going to lead us into what we're doing, okay? I know we're moving a little slow. I just want to make sure we all understand it. All good? Right? Okay. If you have a question, please ask. Let's take a look at C. Part C was x plus 1 squared equals negative 4. Alright, a little bit trickier. Not much. What's the difference with this problem, or between this problem and the last one? What's going to happen here, Nick?
You know it's going to be negative.
Negative what, though? I see a negative. What does that mean? You know it's going to be negative. No? Well, it's going to be what? Say it?
When you like square root everything, you get x plus 1 equals, oh wait, you do with the I.
Yes, there you go. Good, I was waiting for you to correct yourself. So we have a negative 4 we're going to take a square root of, so this is going to have an imaginary root. Remember when we did quadratics, there were some points where it said, determine the real solutions. If there are no real solutions, state that there are none. And that was on one of your tests. And you had an answer where it was like x squared plus 25 equals 0. You moved the 25 over and realized it was negative, so you wrote no real solution. Now we're going to see that we can actually get a solution, but it's going to be imaginary. Okay? So let's square root both sides. Okay, we still put the plus or minus. It doesn't change. It does not change. You take the square root, put the plus or minus in. Now, at this point in time is where we have the negative under the radical, so we move an I out in front. Okay, please remember to do that every time. And the square root of 4, everybody? 2, right? 2. So we're just going step by step and reducing every line. And Johnny, the last step, how do I get rid of that 1? Good. Okay, and again, when we subtract, we just put the negative 1 in the front, showing that we've subtracted 1 from both sides. Erickson, what would our solution set look like? Good.
Negative 1 plus 2i, negative 1 minus 2i.
Very good. Now, we're going to notice something later in this chapter, in chapter 7, about complex, God bless you, about complex roots. Bless you. And what you'll notice is that these complex roots are also complex conjugates. Negative 1 plus 2i, negative 1 minus 2i. These are complex conjugates. And whenever you have an imaginary root, or a complex root in this case, you're always going to have them in pairs. Always, always, always. So if you had an equation that was x to the 8th power, you could have 4 sets of complex roots, giving you 8 total roots. And we'll talk about how that comes about later on in the year, but you're always going to have complex roots in pairs. Write that note down, please. Complex roots always come in pairs, and they are complex conjugates. Okay, complex roots always come in pairs, and they're known as complex conjugates. All right, last part. Let's take a look at part D. X squared minus 4x plus 4 equals negative 5. This is similar to the one that we did in the warm-up, right? At the very end of the warm-up before. Was it plus 4x or minus 4x? What did I say? Minus. Thank you, Mike. Again, x squared minus 4x plus 4 equals negative 5. What do we do in the last warm-up to make this easier on us? Because we clearly could try and move the 5 over, and we'll get a 9 as our c value right here. Okay, as our c value, you move this over, this will become a 9. But 9 does not factor into anything but 3 and 3, which don't add up to negative 4. Erickson. Yeah, so factor, what do you get?
X plus 4, x minus 1. Oh no, x minus 4x.
Manny?
Oh no, x minus 2, x minus 2.
Good. Okay? So it's minus 2 there. Now, Erickson, the first thing you would notice here for a problem like this, there's a good chance they're going to repeat themselves. Okay? So remember when you started with 4 and 1? If you had 4 and 1, we can't write this as a square term anymore. So it wouldn't work well, right? So think about that way when you're doing this. All right, so this is squared equals negative 5. Take the square root of both sides. What kind of a root do we get? Minor. Imaginary. Very good. Okay, so we write this as x minus 2 equals plus or minus I root 5. Can you take the square root of 5? Does it reduce anywhere? No, it doesn't. So leave it. Don't worry about it. So this root, in this case, is not only going to be complex, but it's also going to be irrational, because we cannot reduce that square root of 5. So we have an irrational complex root for this one, or roots. Let's move over the 2. Let's add it to both sides. All right? And then finally, let's write our solution set. Manny, for the solution set, please. Good. Okay? So again, these roots here are not only complex, but they are also irrational. So this is going to sound weird, but this is a binomial complex conjugate. Remember how we talk about binomial conjugates where they have the radical? So like 2 plus root 5, 2 minus root 5, we call them binomial conjugates. And then 2 plus I, 2 minus I are complex conjugates. So if you were to give them a name, you could say they're binomial complex conjugates. You wouldn't say it, but just to think about that.
If you had, for example, like 2I over 4, could you simplify that?
Yeah, into 1/2 I or I over 2. The real number component can always be simplified, okay, if possible. All right, so here's what we want to think about. This last part, part D, shows us that what we can do is we can always transform an equation that looks like this, ax squared plus bx plus c equals 0, into something that looks like this, x plus q quantity squared equals r. Okay? And that's our goal for today, to be able to transform equations like this. Now, the question you might be asking is, well, Mr. Howell, those worked out perfectly because you made them that way, right? But what if they don't work out perfectly? Then what do we do? Okay? And that's the method of completing the square we're going to talk about. So what happens if, for example, that last problem, it was x squared minus 4x plus 4, which Erickson told us was just quantity x minus 2 squared. So that worked out really well. But what happens if it's not something like that? What happens if it's x squared minus 4x plus 5? It's not going to work, right? So we have to do something to manipulate the problem. And that's what we're going to work on today. Okay? So let's take a look at the next example. And this is one where you'll see that right away. We have x squared minus 10x plus 3. First, can this be factored the way it is? Absolutely not. Okay, I see one person shaking their head no, someone saying no. We cannot factor this. Think about the factors of 3. 3 and 1, right? Is 3 and 1 ever going to give you negative 10? No. So it's not factorable. Now, with that said, what number, if I were to get rid of the 3, erase the 3 from your memory. Just write it like this now. Okay? And leave everything else blank. Leave it blank there and don't write anything on the right-hand side here. What number could I put there for C instead of 3 that might make this factorable? Can anybody think of a number that can go in the place of that 3 to make this factorable?
Positive 25.
Positive 25. Why do you say 25?
Because minus 5 minus 5.
Good. So what you're saying is, well, if you just put a positive 25 here instead of the 3, right? Doesn't this become x minus 5, x minus 5? Okay? In the other class, somebody mentioned 16, which also works, right? Because you could have negative 8, x minus 8, x minus 2. But remember, the goal is to get these to be the same. So, Katarina, you're absolutely right. We should use this as 25. But you can't just make something 25, right? It's not mathematically, allowable or legal in a sense. So, we have to think about this. We still have this 3 in the beginning. If I don't want this 3 over here anymore, just move it over. So let's put a negative 3 on this side over here. But if I added 25 to the left-hand side, what do I have to do? Add 20, nice and loud.
Add 25 over to the right hand side.
Yeah, to the right-hand side. What you do to the left-hand side, you have to do the right-hand side. This is our additive property of equality. We can add 25 to both sides completely. It doesn't affect the problem. So the right-hand side becomes what now? 22. And now we can solve this. We could say, all right, well, you know what? This is x minus 5 squared equals 22. And then we can solve it the same way we solved the last examples. Square root both sides, and then add 5 to both sides. Okay, again, take the square root of both sides. You're going to get x minus 5 equals plus or minus root 22. Add the 5 over, and here is our answer. Okay, 22 is only 11 and 2, which are not perfect squares, so you can't break it down. All right, let's write it as a solution set, but is this clear what we're doing? Okay, we're coming up with a technique so that we can solve for x. Now, keep in mind, x is a number. This is a value. Who has a calculator in front of them or nearby? Thank you. Tell me, Alejandro, do 5 plus root 22 and give me a decimal estimate, and then do 5 minus root 22. Okay, and we're approximating. It's going to be 0.309. So, we have two answers for this problem, 5 plus root 22 and 5 minus root 22. And that seems to confuse students because they're like, well, I solved for x, it should be a number. This is a number, okay? It just happens to be some irrational number. Okay, and these go on forever with no repeating pattern. Okay, so these are irrational numbers. We are approximating with decimal values here. But I want you to see now, if you went back and you checked it, go to your calculator, Alejandra, and do the 9.69. And it's not going to be exact because we're rounding, keep that in mind. But go ahead and do 9.69 squared minus 10 times 9.69 plus 3. And you're going to get a round 0. It's going to be a little off, obviously, because we rounded our answer. What do you get when we run a check through this?
Plus 3?
Plus the 3, yeah? So the original equation.
Negative 0.0039.
Yeah, okay? So again, the answer should be 0, obviously, but because we rounded that first one, there's going to be what's called a cumulative rounding error, which is fine. But the idea is that this is very, very close to 0, isn't it? So it does check out. So this check is one of those checks where you have to assume it's working now, simply because we rounded. That's why you're going to see that differential there. Had we not rounded 9.69, had we used, say, for example, the exact solution, which we know is 5 plus root 22. Imagine we square that in the calculator, then minus 10 times the quantity 5 minus plus root 22, close parentheses, plus the 3. You will get exactly 0. I guarantee you will get exactly 0. Okay? So if you were to take this quantity and run it through the original, you'll get 0 equals 0 exactly. Because this is an exact answer, whereas the decimal is an approximation. Okay, so what we're doing today is we're coming up with ways to solve any quadratic to give us our 2 roots. Okay, to give us our 2 roots. It worked, right? So I should lift her head with a smile. It definitely works. So these are our 2 roots for this equation. Okay, these are the 2 roots. These are the decimal approximations. Let's write down a little bit of a trick or a little bit of a rule to do this. Okay? Before we do that, I'm going to write down, anybody notice something about this problem? Like, Katarina, you picked 25 and that worked out conveniently, but it might not work every time to just pick numbers. Did you notice, where does the 25 actually come from? Do you have any idea where that stemmed from? Okay, it is a perfect square. And what else in this equation looks like a 5 or has some 5 in it in a sense?
10?
Yeah, what is 10 really?
5 plus 5.
Yes, or 5 times 2, either way, right? So, if you look at the middle term, and you take half of it, it's 5, isn't it? Or negative 5 in this case. And then if you square that and add it, it'll work. So that's what we're going to do today. And I know you've seen it already, so your hand. So you have the middle term, and add it over here, and it will always work. So we're going to write down some steps, though. This problem is easy because A was 1, so we have to be careful. So these are going to be our general steps. Okay? So, general steps for completing the square for the following equation. Ax squared plus bx plus c equals 0. First step. Transform the equation so that c is alone on the right-hand side. So that's when we move the 3 over. We subtracted 3 on both sides for the beginning. Step 2. If a is not equal to 1, which we didn't have to worry about because a was 1 in our problem. If a is not equal to 1, then divide all terms by a to make it 1, which will give you a new b, new a, and a new c. Okay, it'll give you new values for everything. Next, add the quantity b over 2, which was like the half of the 10 in the middle, b over 2 squared to both sides of the equation. Now this next part is very key, number 4, and this is something that a lot of students don't get, and I'm going to explain it to you. So in the last example we had this. And this factored into, right? We had x squared minus 10x plus 25, and that equaled something else. It really didn't matter, 22. But that's what we had in the last example. And the first thing you're looking at is, all right, what the heck does this mean, Mr. Howell? This x plus or minus b over 2 squared, right? Well, the plus or minus is there because depending on the middle term here, if this were positive 10x, this would be x plus 5, x plus 5. Because it's a negative 10x in the middle, it's x minus 5, x minus 5. So this could be positive or negative. Now, b over 2 is just this 10 here over 2. And 10 over 2 is just 5. That's where this 5 is coming from here. Okay, so this x plus or minus b over 2 is simply saying, take half of this value here, square it and add it, but then when you factor, take whatever half of that value was and move it down here. So if this had been an example, instead of a 10x here, if this had been something like 64x, then this would be 32. If this had been 100x, and obviously this number would change, but if this had been 100x here in the middle, this would be 50. If this would have been, say, a half of x, this would be a quarter. It's whatever half of that middle number is what it's going to factor into. And it helps a lot to pick up on patterns like this. Left-hand side. And RHS is right-hand side. Okay? And then the last step, 5, is just to solve for x. Okay? Step 4 doesn't seem very important right now, but on the last example we do today, you're going to see it's extremely important. Because it's very tough to factor the last example unless you remember that step 4. Okay? So let's take a look at the next example and let's heat all of our steps here. Let's go step by step and think about what's happening. So here, x squared plus 6x plus 13 equals 0. Erickson, what was step 1 for this problem? What was step 1? Good. And watch what I'm going to do, by the way. I'm going to leave a little blank. Because clearly we're going to add something there, right? Mahanor, what's half of b in this problem? 3. What's 3 squared? So we take 9 and we add 9 here. And we add 9 here. Again, immediately move the c over, take half of b, which is 3, square it, and add that value to both sides. And now it's a perfect square. Katarina, what do you get?
X plus 3 squared.
And notice, remember what I said? Half of b is 3, right? And the 3 shows up right here. Again, whatever b is, right here, take half of it and put it right here. Okay? So combine like terms over here. What do you end up getting for that? Take a square root of both sides. What kind of an answer am I going to get? What kind? Alejandro? Imaginary. Please don't forget that plus or minus. A lot of people forget it when they see that there's already a minus on the right-hand side. The minus on the right-hand side is under the radical, though. The square root of negative 4, we could take I out, like that, make it a positive 4, and then the square root of positive 4 is just 2. Subtract 3. Nick, what do you get for the final answer here?
3 minus 2i and 3 plus 2i.
Very good. And Jules, tell me, what are these called again when it's 3 minus 2i and 3 plus 2i?
Why is it 3? Is it a positive 3? It's negative.
Negative 3, thank you. Sorry. I said yes, Nick. Negative 3, sorry. Thank you, Jules. What do we call these, though, again? Sorry. Complex conjugates. Very good. Complex conjugates. My mistake. Put the 3 over as a negative. Again, because we're subtracting the 3 here. Okay, so our answers are negative 3 minus 2i and negative 3 plus 2i. Is this okay so far? All it is rules. And I'll tell you right now, the thing that's going to make this a lot easier is just doing the homework for this. That's it. Practicing these problems. You need to have the steps memorized for sure, but it's not tough to memorize. Move the c over, get rid of a if it exists, add half of b squared to both sides, factor, solve. Eric's,
Will there be examples where like there's a number in front of x squared?
there's a number in front of x squared. That's what we're going to do next. Yep.
Can I use the bathroom?
Wait till after the example. Let's do this last one here. So we start by moving the 3 over, right? Let's do that. And I'm not going to leave it blank there yet, simply because we still have to get rid of the a value. So step 1 is to move c over. Step 2 is to look at the value of a. And if it's not equal to 1, we should divide everything by that. So what are we dividing everything by in this problem? 2. Recommendation, and not a recommendation, I'm telling you, leave it as a fraction. It'll make your life a lot easier. Do not convert to decimals when you're completing the square. Write a little note on the side, please. Do not use decimals when completing the square. It makes it much more difficult. Okay? Now, at this point in time, we have to think about what half of b is, and this is where it gets tricky. b is already 5 halves. How do you have 5 halves? No, not a calculator.
Double it.
Double what though? The half, so it becomes 5 over. Very good, Johnny. So remember, when you divide by 2 or when you have something, just double the denominator. Okay, so the value that we're going to do is we're going to identify, we're going to say that we need to add not 5 halves squared, but 5 fourths squared. So let me show you what I mean. Remember, we have to do this, right? We have to add this quantity to both sides. Well, half of b is just 5 fourths, and that quantity squared is going to be 25 sixteenths. Okay, so what it looks like now is this. Okay, that's what it looks like. It's a bit messy, but it's actually very easy to factor. It looks like, how am I going to factor this? But if you remember the rule I told you, that the factor that occurs here is always going to be x plus or minus b over 2. Just look at the number we use for b over 2 over here. Remember this 5 fourths right here? That's what's going to show up in your factor. That's how easy it is. You don't actually have to factor this. What you're going to get is this. We'll have to combine like terms on the right-hand side, but that's what it's going to be. Remember, whatever b over 2 is going to always show up here. If this sign right here had been a negative, then this would be a negative. Since this is a positive, this is a positive. Half of b is 5 fourths, and that's always going to be here. Always, always, always. So you don't even have to know how to factor this problem, because honestly, it's tough to factor this just to look at it. It is not easy at all to see that. But if you FOIL that back out, it will turn out to be the quadratic on the left-hand side. Now, on the right-hand side, how am I going to add 3 halves and 25 sixteenths? Erickson?
Change 3 over 2 into 24 over 16.
Yes, so instead of, I don't want to cross it out actually. That's annoying. I wanted to erase that. Okay, there we go. So we're going to get here, let me write the left-hand side. We're multiplying the top and bottom by 8. Okay, we get a common denominator. So we get 24 over 16 plus 25 over 16. Well, that turns out to be 49 over 16, doesn't it? Convenient. Why is that convenient? Katarina? They're both perfect squares. Not always going to work. Okay, not always. Sometimes you'll get something that's not a perfect square and you have to leave a radical behind. But when we take the square root for this problem, we're going to see that it actually works out very nicely. So take the square root of both sides. Square root of 49, everyone?
7.
Square root of 4 is 4, and a plus or minus, don't forget. Okay, so again, we're really taking the square root of both sides here with the plus or minus. So we get y plus 5/4 equals plus or minus 7/4. Let's subtract the 5/4 from both sides. And this is an example where when we subtract the 5/4, we can now separate it and actually get numerical quantities because there's a common denominator there. So let's do this in two parts. And we're going to simplify these. Okay, we're going to break it up because it's plus or minus and then simplify. Summer on the left-hand side. What do you get?
1/2.
Very good. 2/4, which is 1/2. That's one of our roots. On the right-hand side, real quick, Nick, what do you get?
I didn't do it.
Negative 12/4. Very good, Nick, which is? -3. By the way, go back to the original and factor it. You'll get the same answer. This one was factorable. I didn't tell you that on purpose. But if you go back to the original, you'll get factors that look like this. 2x minus 1 and x plus 3. And that's the same answers you would get. There's homework over the weekend. The problem set, the one that's not due until the 28th of February, is online for you to start if you want to. Again, it's already on there. I can show you your partners right now if you want to see. Absolutely. You too. Have a great Valentine's Day.